Good morning. Thank you for being here this morning, bright and early, and it is my great pleasure to welcome all of you to the first tutorial in our tutorial series in Phoenix this year. This morning we have a very interesting and timely tutorial on digital twins. And I have known Bahar and Stefan since grad school, so it's very special to me that I am introducing Bahar this morning. I have followed their amazing research over the years. Bahar is currently a principal OR specialist at the SAS Institute. She is a past president of the Informed Simulation Society, and she has published widely and she has received many awards for her research. Stefan is a distinguished professor in the School of Industrial Engineering and also at the School of Business at Purdue University. And Stefan's expertise includes smart manufacturing, digital twin, and supply chain management. Jinshin Ye is the Director of Analytics Center of Excellence at the SAS Institute. Before passing the word to Bahar, I would like to thank Doug Shear for all his help as the Editor-in-Chief of our tutorial series.
Thank you all for getting up so early, but this is a great way to start the conference and to start your day. I did want to mention that, of course, things will be available digitally when you log in, but also there's always nice to have something that I like to pull out of my bookshelf. So this is available at your local bookstore, which means at the Informs booth. So it exists, and it's really nice to be able to have this encapsulated. So welcome, and I look forward to an excellent talk here. Thank you.
Thank you very much, and thank you very much for the opportunity to talk here today, and thank you for just getting up so early and coming to the session. So I am Bahar. I am working at SAS R&D organization. Jinshin is my director, and let me tell you a little bit about how we are kind of positioned in the company. So we are in R&D, however, we are in a group called Analytics Center of Excellence. So we are like the consulting arm of the research and development. So this gives an opportunity for us to work with the clients, and in the remaining time, motivated by the difficult challenges we see, we also spend some time doing research, industrial research. So it was just several years ago that we started to get a lot of questions from our clients about what's a digital twin? Do you have a digital twin product? So then we realized, okay, we really need to learn what a digital twin is. So we formed our internal working group and just studied, and then more importantly, we asked the questions, the work we have been doing, does it qualify as a digital twin? And if it does not, what we are missing? So, and then what we can present to our clients and how we can actually establish what might be our differentiators. So we started to study and learn and understand with that objective in mind. And today what I'm going to be doing is I'm going to be sharing our learnings and experiences over the last several years. So I'm going to start with what a digital twin is, with its formal definition. Then I'm going to be introducing what we think the foundational elements of digital twin development are. I'm going to be spending some time on the key functions and enabling technologies. The way we view digital twin is that digital twin is not a product. It is a concept, and then we bring at SAS the enabling technologies like statistical modeling, optimization, simulation, AI, machine learning, computer vision, natural language processing all together, and then we just use them in an integrated manner, and this is how we develop digital twins. So this is why the part about the key functions are important. Then I'm going to be introducing 3 different development frameworks that we have actually found quite useful in our work and in our communication with our clients. And then I'm going to be showing you several use cases. Most of them are already in the chapter in the book that Doug has just shared with you. And when I just talk about things that might not be there, I'm happy to share the slides with you as well, if you see discrepancies, but I'm just going to be pointing them out. All right, let's start with what digital twin is. What we like to do is actually use the digital twin definition of the digital twin consortium. So the digital twin consortium defines digital twin as a collection of real-world entities and processes that are synchronized at a pre-specified fidelity and frequency. So what might be a real-world entity? So it might be a machine, it might be a pump, it might be a truck. What about a process? Factory process flow, supply chain process flow. So this is how we distinguish between actually whether we are looking at an asset or we are looking at a process. Can you specify a flow that entities follow in their facility? So this definition basically says that there must be 4 main characteristics that you need to have in your solution so that you can say it's a digital twin. So first, there must be a physical representation, there must be a virtual representation, and then, more importantly, these physical and virtual representations must be synchronized with each other. Synchronization is basically calibration, but it is a series of recalibrations that you do over the life cycle of these assets and processes. And then the ability to learn and adapt. So the last item is actually means that you need to have a closed feedback loop between the physical representation and the virtual representation, so that your digital twin actually continues to live in a learning environment. So that last item, learning, is the most important piece. So when you just start reading about digital twins, so you might just see different kind of like types, component twins and part twins, asset twins and process twins. I just like showed on the screen the asset and process, and that's what I'm going to be focusing on. So there's also, of course, component twins, part twins, where you basically focus on an individual part and you perform an isolated analysis. And when you do predictive maintenance practices, generally this is what you work with. So, for example, computer-aided designs, CAD, just falls into the first category. So this is often not what we work with, and that is not actually our chapter and what this presentation is about. I'm going to be focusing on asset twins and process twins. However, there's a whole wild world about the product twins as well. And if you are interested in those, I would be happy to talk to you and provide you the references that you might like to utilize. There is one more topic that I'm not going to be talking about today, and that is called digital thread. So if you are interested in actually developing a digital twin solution in your company, digital thread is also a topic that you need to get familiar with. So today we are going to be talking about what digital twin means for a customer, for an end user, and that is what I consider myself as an end user. However, what about the developers? How do you explain the digital twin development to a developer? So the part we are going to be talking about today is about what? What's the digital twin? And then how part, in terms of the architecture you need to build, but detailed architecture you need to build, then you need to move on to the topic of digital thread. So I just provided some references in the chapter, but again, I would be happy to talk to you in more depth if you would be interested after the presentation. Occasionally, I'm going to use the terms like factory twin and supply chain twin. It just means that I'm looking at really the process twins, where you explicitly model the process flow as you are creating the virtual representation of the physical system that you're interested in. And I'm going to be basically using the twin name to add factory and supply chain. I will also share some use cases. Actually, we treat factory twin as an asset, because there will be an application where we are going to be thinking of a factory, but we are not going to be explicitly modeling the process flow. Instead, we are going to be focusing on certain assets in the factory, and we are going to be asking, okay, what are the optimal operating settings for this machine? So therefore, I'm going to be working with my X's and my Y's. And there, often what I'm going to be using event stream processing capability. And I'm going to be using machine learning and optimization capabilities. So at that point, I'm going to say I'm working with an asset twin type. All right, so, and another thing I would like to mention is that because we said digital representation and virtual representation. And actually my background is also in simulation, so I often work in projects where we develop simulation of complex business systems. So then there's the question, okay, we have a supply chain network simulation. Do we have a digital twin then? So, no, the answer is no, because yes, you have a digital representation of a physical supply chain, but you need to enable synchronization, and you need to enable a closed feedback loop between the digital model you create and the physical system that exists there. So that is an example of an one-off project. And that is when you are actually doing offline development in a way. So once you add the synchronization, which was the third required characteristics, and closed feedback loop that enables ability to learn and adapt, which is the fourth requirement, then you can just claim that you have a digital twin solution on your hand. Digital Twin Consortium. So if you would like to learn about digital twins, you should be aware of this organization. So this is where academicians, practitioners, governments, research organizations come together, and their mission is to better understand what digital twin is and just find common ground about what the digital twin development requirements are. So I also provided in the chapter the link to the website. It's also here too. It has a steering committee composed of certain companies. And then I just took a snapshot about the working groups. So depending on the industry you are from, so you might definitely find resources for yourself if you learn it a little bit in depth. But customized to the industry, and then it has also blogs, webinars that you might find useful. The webinars are quite at high level, so it will just give you a good introduction, but of course when you just get to the development steps, when you just need to be hands-on, they might be just a little bit like at a higher level. But that is a great place for it just to start, just to check out. And I still actually check what webinars are available. I have a webinar to go to on Tuesday. And they just had one on the 11th about a digital twin-based remote operations center for wind farms. So this is something that you should definitely check out to learn more and just see what there is for you customized to the industry that you're interested in. Digital twin foundational elements. So if I am actually developing a virtual representation of a complex business system and I'm going to be enable synchronization and closed feedback loop, these are quite difficult actually tasks to perform. And when we are talking to our clients, of course, they have complex problems. So where can we start where everything is relatively simpler and we can start from there and go towards the more complicated task in a structured way. So at that point, we just started thinking about what the foundational elements of digital twins might be, and we decided to come up with those four: data, domain, advanced analytics, and outcomes. Later, I'm going to be introducing three development frameworks, one of which is not an official framework. That's the one that we utilize. And we built on these four foundational elements, and it just serves us quite well in our projects, actually. So the data, it basically contains all different types of data. So this is comprehensive from our point of view, But of course, there might be items that might be missing in the list that I'm showing here. Of course, this is also motivated by the projects that we are working on. So in terms of description and in terms of frequency, the data might be coming from engineering design, it might involve expert opinions, it might involve video and audio, so computer vision also provide a way of collecting data from the systems, historical data, MES, manufacturing execution system data. So there are all these different sources of data, and we put them under the data element. And of course, we talked about the closed feedback loop and synchronization. So how often you should actually recalibrate your digital model? It really depends on the speed of your decision making. If your speed of decision making every month, then you don't have to probably calibrate your model every hour or every day. So therefore, that frequency I put on basically covers everything. It's really dependent on the use case you have and also where you are on your development. Are you at the very beginning of strategic phase, or are you at the tactical planning phase, or you are already working on how to operationalize the work that you have been doing? And then there is the domain element. So that is, of course, the most important key component of all, because the domain expertise is the one that keeps everything. For example, SAS Institute, we are an analytics company. So we don't have the domain expertise like a hardware company would have. So therefore, it's very important for us that we collaborate with our clients. We work with our partners who bring in the domain expertise piece. So who will provide the domain expertise is very important. And then, of course, advanced analytics. So this is the component that, as the Informs community, we all have and you have been contributing to. So the pieces that you see here, function details and learning details, that I'm going to cover under key functions and enabling technologies. But simulation optimization, machine learning, AI, statistical modeling, none of them is new. What is really new about digital twin is what cloud, edge, and IoT have enabled us to do today. So they enable us to create this closed feedback loop so that when you actually get your insights from your analytical models, you release them into the real system, and then through IoT sensor data, you just get new data sets that actually capture the effects of the decisions that you had just done. So then that data comes, and hence you have your closed feedback loop. So therefore, even though we are talking about the digital twin, I'm sure that you all have been contributing to the digital twin development effort. So that synchronization and closed feedback loop would be the additional pieces to put on top of it. And then the outcomes. So this is also very important, because when we start the digital twin conversation, it has to be very clear what use case we are talking about. Otherwise, it's very comprehensive. So you always need to focus it on a use case, and you need to make sure that the outcome that you are saying you are going to be achieving must be clearly defined, and it must be objectively measured. So that is also very important. Here under customized use cases, I just went a little bit narrow, and I just put in supply chain because our group at SAS Institute works on supply chain projects a lot. So I just put them here this way, because when we think of supply chain analytics and when we just think of the projects that we work on, these are the high-level categories that we often encounter. So the promo optimization, where you are trying to identify the optimal promotions. So this is, again, very high level, but frameworks when you are taking complex problems are always very helpful. You start with your sales history, bring your promotion history, and you do promotion analysis, and then you make several additions, and then you find your optimized suggested promotion. So this is why we've just put it in there. Demand forecasts, creation of the statistical forecasts, inventory optimization that actually takes the distribution networks and demand forecasts with promotions at a very high level. So this is why we have these components and we put them into our high level definition of what an outcome is. And actually one of the use cases I'm going to be presenting later is going to be on development of a supply chain digital twin, and some of these components will be there, including the one that we are looking at on the screen now. So this is the step where we have a supply chain network simulation. It's an end-to-end simulation that just brings everything together. So this would be a virtual representation of a supply chain, but it has to have synchronization and it has to have closed loop aspects to it. If I would just leave the simulation piece like that, I develop it, I verify that it has no bugs, I validate it with the historical data, and I make sure that you have now confidence that it can mimic what you encountered in the past, and I give it to you. So then this is not a digital twin yet. So I just did a one-off project and I delivered it to you. When we work with this last step, and this is the reason why the digital twin concept in the supply chain setting becomes a little bit difficult, is that depending on where you are in these boxes, your time units might be different. So often when we just do simulations, our unit of time might be an hour, or it might be a minute. So if your production plan, what you are going to produce for each part on each production line, is based on a weekly basis, it's not good enough. You need to just reduce it to the level of the minute, and you need to solve a sequencing problem before you give that solution to me. So therefore, when you bring all these pieces in a supply chain sitting together into a supply chain network simulation, you need to make sure that the time units match with each other. And of course, this also brings the question, okay, what is the frequency of synchronization that you need to do for each of the different parts? So I think individually, these are the problems, again, we have been working on, but then in the digital twin concept, you just need to think about how you are going to be integrating them. And that's basically the additional piece to it. All right, so this is why I have this limited view of customized use cases. If you are working with clients or if you are a vendor, depending on the industry you are working with and depending on the use cases you are encountering, I suggest that you take it and just customize it to that. It's all about making the communication clear and what you would be developing transparent. So another reason we just like this foundational elements is that you develop supply chain digital twin for one client. When you are trying to do another development for a different client or for a different part of the organization the client has, you don't want to start everything from scratch. So the idea here when you are doing digital twin development is just to modularize the tasks. So you should frame your development in a way that it can be modularized, so that when you are doing a new digital twin development, you don't start from scratch. It's all about learning. You need to build on what you have learned, and it also enables you to manage your resources in a more effective manner. All right, so these are our 4 foundational elements, and this is actually where we start our conversation with our clients and answer actually what the differentiators we have. So if you are a vendor, then this is a question that you might be very well asked. If you are not a vendor but client, you should definitely ask the vendors you are talking to what their differentiators are. So for us at SAS, that is streaming analytics and SaaSVia. So this is our cloud native AI platform, and event stream processing. So this is basically that takes the IoT data in real time into the system and enables us to, in a very effective way, perform edge analytics. If the computations are complex, of course, you can often, when you are working with the process twins, you take them to the cloud, or you might be on-premise as well. So, but this is one aspect of it, and another is execution and experience. So again, we are a company who have been doing analytics for so many years now. So the digital twin concept parts of it are actually not new, but the synchronization piece and close feedback loop are the most important things. And this is why it's also very important that we very closely work with our customers, because enabling that synchronization and close feedback loop is something that also requires their commitment. And, oh, I'm sorry, this happens lately. And again, as I mentioned, we are an analytics company. We bring the advanced analytics pieces, we can deal with data, but then for the domain piece, the partnership flexibility we have at the SaaS is another distinguishing differentiator for us. We work with our partners so that we bring in the domain expertise in that manner. All right, key functions and enabling technologies. This is how we like to think about it. We just like to think that there are three primary key functions motivated by the definition of a digital twin: offline model development, real-time synchronization, and online learning. So, offline model development, we often start with assumptions, historical data, domain expertise, and we develop our virtual representation, we develop our digital model. It's important that we validate it with the historical data so it can actually kind of like mimic what you observed in the system, but you are still working with historical data. There is no real-time data that is streaming into the model yet. And then you provide your insights. And then this is the end of the offline model development. The moment you start actually synchronizing your digital model with the physical system, you start your recalibrations, then your real-time synchronization will be starting. And this is followed by the online learning. And this is the part where you are monitoring the system, tracking the past, and then you are doing your usual prediction and optimization task at this part. And the results you obtain at this point are not just insights anymore, they are controls. So this is when you are prescribing what actions actually the physical world should implement. And they take them and then they implement it, but then you still continue to receive data from this real system. The data you are receiving now will be including the effects of your decisions that you already made. So that is the closed feedback control. So of course there might be disruptions that might have taken place. They will be all part of the new data that will be coming in. This is just another illustration that emphasizes that there are key three functions, which are offline model development, real-time synchronization, and online learning and controlling. So therefore, when you are working, it's important to distinguish between or among verification, validation, and calibration steps. Verification, when we are doing simulation projects, it just comes up. You make sure that your digital model does not have any bugs in it. You verify the model. Validate is that you have the historical data, and you ensure that by looking at the historical data, using your digital model, you can produce the outputs that you had already seen in your historical records. And then the last step is the calibration. It's really the real-time synchronization piece. So you want to be at the very end with the close feedback control so that you can claim that you have a digital twin solution on your hand. And enabling technologies, as I had mentioned in the very beginning, at SAS we don't have a digital twin product. We think of it as a framework that is defined in this way, and then we bring actually technologies together, integrate them depending on the use cases we have, and this is how we develop digital twins to meet our clients' needs. So I just have several examples of enabling technologies, and I'm sure that most of you might be working on different aspects of it: AI, ML, simulation, forecasting, optimization, visual analytics, streaming analytics. Of course, in our group, we are often working with supply chains, with operational systems, but of course you might be in the finance industry too. So the concept of digital twin just goes in there too, and at that point you might be utilizing econometrics is another digital twin enabling technology. So when we talked about predict and optimize, that is again something that you might be already familiar with in your supply chain analytics work. You might be just using, for example, a discrete event simulation and just obtain predictions about how your system might behave. So when we think of these digital twins, we have been talking about digital twins, but how you utilize it. There are three ways that you use the digital twins, or with three different objectives. You might use it to replay the history. So basically our client just takes the digital twin solutions, loads the past data into it, and then just sees what happens, and then asks, okay, what if we had done it differently? So what would happen? So they can use it to replay the history, and then it can be used to predict the future, to predict the health and performance of the assets and processes. And finally, it's just for prescribing things. So this is a topic that we are all familiar, right? So descriptive analytics in a way, predictive analytics, and prescription analytics is what I'm talking about here. So this is about the second part. It's the prediction part. Suppose that we have a supply chain network. On the x-axis, you have the time. On the y-axis, you see the supply chain fill rate, my predictions about how it might play out into the future. On this plot, you see a series of box and whisker plots that captures the uncertainty. So it's another thing that if you are just using simulation, it enables you to quantify the risk in your calculations. So here I just see an interval where my fill rate dips. There is a problem, and of course, if I am using a tool like a simulation, a supply chain network simulation, I am collecting a lot of data. What is simulation? It's a data generation program for the complex system I have, but it's still a data generation program, so it just produces a lot of data just for me just to use. So here, basically, I'm looking at my average buffer lengths and the standard deviations I identify with them. And I just then trace the reason of that dip in the supply chain fill rate to a capacity issue I'm having in one of my plants, in this particular use case. Once I identify the bottleneck, now I just need to search for the best course of action I need to take. So this is the prescription piece. So, and this is also the part, the topic of resilience testing might just be coming in. So when we just do future-looking resilience testing, we are not trying to predict whether actually a disruption is going to occur or not. We do not look into the estimation of the probability of a disruption. We assume that a disruption is going to happen. We enforce it into our digital model. And then in the step, we just like ask ourselves, okay, what are the best actions to take if actually we encounter a disruption? So this part is really about coming up with a playbook of decisions that you might take in the case of running into disruptions in the future. So this is how we approach the resilience testing. So once you determine what you should do, this is the control piece, then you can just, in an automated manner, release it into the system, or you can just do it in an augmented way. When I say augmented, there is a human involved. You don't release the decision into the physical system right away. And in most of our projects, actually, what we are doing is to have the human in the loop as well. All right. This completes looking at the key digital twin functions. Now, I would like to share with you 3 frameworks that you might find useful if you are looking into digital twin development. One of them is the digital twin cube. It's very high level, but again, these are just like frameworks that might enable you to get the conversation started about digital twin development, especially if you are in the beginning of your journey towards digital transformation. Then we are going to look at the digital twin capabilities periodic table. And then I'm just going to be showing you what we often use built on those 4 foundational models. And we had just published it last year as tutorial in the Winter Simulation Conference, and we are going to be also talking about it this year as well in December. Let's start with the Digital Twin Cube. This was reported by Digital Twin Insights report in 2020. This is having 3 main dimensions to describe the concept of digital twins. In one of the dimensions, you see the life cycle phases, which goes from design, build, operate to maintain, optimize, and decommission. And in another axis, you see the hierarchical levels, including informational, component, product, process, and system. And the last axis is the most common uses. Again, this is very high level in case you are in the beginning of the conversation of what a digital twin is. And it just provides 252 different digital twin descriptions, which you might find useful. This is not mentioned actually in the chapter. I'm just including it here. However, if you just enter Digital Twin Cube, I'm sure that you will just find a report. If not, please just reach out to me. I will just give you the right references. The next one is the one, actually, that's the most comprehensive of all. The last one I'm going to show you is what I like to use, actually, when I'm presenting digital twins to our clients. And of course, motivated by the use cases we look at. But if it's you want to go towards an audience that is more general than that, this is something that you should definitely check out. It has 6 different categories: data services, integration, intelligence, user experience, management, and trustworthiness. And it just describes a certain number of technologies associated with each category. For example, simulation model, repository, data aggregation, data streaming, synthetic data generation are some of the topics that you might be familiar with. Synthetic data generation is also a topic, for example, at the SAS Institute, we recently just discussed a lot as part of an emerging R&D technology. So if you have, for example, health data, and you just often you cannot use the data itself, then you might actually use this synthetic data generation method to generate the type of data that you can use. Or if you have limited data, this might be also something that you should look into if you are suffering from the lack of availability of large data sets. And then intelligence, I believe this is where we are all as the Informs community, where machine learning, prediction, reporting, simulation, mathematical analysis appear. And here's the user experience, management, and trustworthiness. I like this whole table a lot because when I personally talk about digital twins, I'm of course a little bit biased by my background. I just don't talk about security of things. I don't talk about the trustworthiness category, but it is just so critical. So that also must be part of the development effort. So therefore, when you look at actually the chapter, I mention it there as one of the important things and challenges, and I give a reference to it, but I don't discuss it at length. So please just don't take it as something that just comes secondary. It's just one of the very important components. And when you look at a factory twin, for example, we had looked at an illustration of it in the very beginning. This is how you can just put those 6 categories. So in the chapter, I just give a link to an Excel file You can also, of course, find it by going to the Digital Twin Consortium website. It just provides an Excel file for each of these 6 categories, and it also provides a reference to everything that you see here for a wind farm operations, treating it as an asset twin. So if you are going to be developing a digital twin framework for your project, for your organization, I strongly suggest that you just give it a look and how they structured it. So this is a good introduction, but I know that I am at very high level. If you want to go one step further and you just want to slowly get hands-on, that would be a great place to start. And of course, I'm always more than happy to discuss it with you and share our experiences. So, for example, at CES Explore, we had our conference in September, and this is where we use that digital twin periodic table to tell what we are covering. So there are a lot of technologies there. Of course, we are not covering all the core, but with the third-party integration and SaaS partners, we are able to cover all the AI and IoT capabilities to develop the digital twins. So this is also something that you might like to do for your organization, or again, if you are a client talking to a vendor, this might be a good technology table to refer to just to understand what they can cover. And more importantly, there is a 30-minute webinar about this particular framework. Just go to the Digital Twin Consortium, as we talked earlier, go to the webinars. It is there. There are a lot of webinars, so it might be a little bit difficult to find it, but it does exist there. So you can also see it from the slide. Again, I'm also happy to share the slides if there would be an interest. This is also referenced in the chapter as well. And again, the important thing is that when you are talking to a client as a vendor, or when you are listening to a vendor, everything about digital twin development should be according to a use case, and you need to have outcomes that can be clearly stated and objectively quantified. So therefore, this particular one that builds on the 4 foundational elements that we already looked at earlier when we were discussing the elements is the one that I particularly like. With the data, domain, analytics, and outcome pieces. We are going to be looking at a supply chain digital twin use case. For that, actually, I'm going to have it highlight those items there where we utilize it. Again, this is a starting high-level framework, right? There's a lot in there. It doesn't say anything about the order. But still, it's very useful in terms of communicating and also in terms of where we are progressed. And I'm going to show something about real-time queue monitoring and resource control. In that particular case, it looks like that. So it is nice at a very high level to distinguish your digital twin development efforts from each other and to see also how they overlap so that you can transfer learnings from one development experience to another. So that's the whole purpose actually of utilizing these development frameworks. All right, some use cases. These are, of course, our experience mostly at SAS. I also provided some examples in the chapter, more general, from solving an equipment selection problem to making an entire factory operational. So I'm not going to be covering it here. We cover production scheduling in more depth, but just today for the presentation, I thought that I should just share this with you. So the asset twins on the right-hand side and the process on the left, and the consumer packaged goods firm use case. This is the supply chain digital twin example that I would like to very briefly go over. So here, the goal is to develop a supply chain digital twin, mimicking the flow of thousands of products through a complex network. And our goal is actually to predict the KPIs. But we would like to use the resulting digital model that, of course, we need to synchronize and for which we need to build a closed feedback loop. We are going to also test the inventory, production, and delivery plans that we create. And of course, we would like to use the resulting digital twin to replay history and also to provide visibility into the future health of the supply chain. This one actually has three main components. But this is a project actually that had started with a focus on production scheduling. We had started with production scheduling without any mention of digital twins. Over time, it just evolved into what it is today, a digital twin. If we had started by just saying we are going to just develop a digital twin, it would probably be going in a different order. So we started with the production scheduling. Every minute, what are you going to be producing on each production line in every plant, including the sequence so that you don't waste time with the changeovers. However, it was just looking at a short term. So the feedback was that how can we actually look what is the optimal way of managing the supply chain when we look farther, maybe into a year. So therefore, we start with the supply chain flow optimization, and I put this here as the first component. That is where you just obtain your optimized inventory planning, weekly productions, and your delivery plans. Right? You will have also trucks who will be transporting parts from one facility to another. Of course, we wanted to combine everything in the supply chain network simulation so we can do resilience testing and replay history, but the production plan that was coming from the first part was in terms of weeks, but the unit of time in the simulation was a minute. So therefore, we had to go into production scheduling and find the optimal sequencing that we can feed into the simulation. And of course, supply chain flow optimization and production scheduling, these are deterministic optimization problems. When you just put them into the simulation, you can also see the impact of the uncertainty. So we didn't solve them as stochastic optimization problem. We solved them as deterministic, and we add the uncertainty in the simulation phase. And then, of course, this was the part where the commitment of your client, your partner, is very important because these models have to be synchronized with the real data. And data needs to be collected in a certain order, in a certain frequency, so that you can build a closed feedback loop. And inventory plans, production plans, how often you should run the simulation, often their frequencies also differ from each other. So we were lucky to work with a wonderful client so that we could actually just deliver the supply chain digital twin for them. All right, so this is a high-level view of the process flow in that particular application. What I would like to emphasize here is that actually we have used various SAS analytics tools to be able to do that. So of course we need the customer demands. So that is where we were utilizing actually SAS's forecasting tools. Then the demand comes in, goes to your warehouses or supply houses, and then if there is inventory, you push them to the customer, but then you need to have a certain inventory plan in place, and you need to have a certain production plan in place, so this is when optimization comes into play. And then the question was how we can actually develop a flexible, completely data-driven and scalable solution. It would not only work for a couple of plants, one distribution center, but it can just work for hundreds of distribution centers, tens of plants. So we designed the simulation here in a way that you read all the inputs from data files. If the configuration involves one of each, then it should be directly read from the data file. If you are going to have hundreds of these links, they should also be in that data file. So depending on the scale you are changing, as a developer, I should never put my hands into your simulation anymore. So that data-driven aspect is very important. And of course, another aspect that is very important is that you are going to be synchronizing the simulation, and there's a closed loop feedback aspect of it. So you need to have the warm start, ideally hot start, but at least the warm start. So you need to start your simulation not in an empty state, but to reflect the state of your supply chain at that moment. So therefore, even if you are in the offline model development phase, it would be great that you think about how you should design your simulation so that it can really do that warm start aspect of it. So that is very important. So we don't do in this project any steady state simulation anymore. We don't do starting the simulation in empty state and then warm start it, and then determining how many data points collected initially should be thrown away. So this is directly a terminating simulation with an initial state representing the snapshot of the system. In the chapter, we reference an hospital management system with that hot start capability, and one of the authors and developers, my wonderful colleague Onur, is also here. If you would like to talk about how they also developed that particular application, which is kind of similar to the concept that I'm talking here, but not in a supply chain setting, but a hospital setting. There is also a reference of it in the chapter. And simulation, and then the AI ML. We utilize the machine learning tools a lot to sometimes replace simulation or parts of the simulation with surrogate models so that we can just do scenario analysis in a fast way. So when the client wants the result scenario analysis to be performed much quicker, actually it can be performed in that way. All right. Often when we talk about the supply chain digital twins, the question comes about, what are the data sets you are using? And this is the high-level answer I often give. So these are the high-level descriptions of different data sets you need really to feed into that visualization that we just looked at. And of course, you might have your data in a time-stamped manner, and then you just need to transform it in a way it can be fed into a simulation mimicking the behavior that we have just seen. If you have projects like that, I would be happy to talk to you. When I first saw the timestamp data, I was always so used to having my inter-arrival times, service times, failure times be handed to me, already clean. So I had never started from a timestamp data. So it was, for a moment, I had just like, okay, what am I going to do? So, but there is a nice transition that you can do so that you can actually simulate the timestamp data as well. And of course, the disruption, event characterization, you should make sure that the outages can be incorporated into your simulation. Using our tools at SAS, I often treat it as another entity, the outage entity, but again, it's because of the tool I am using. So you should think about how you are going to enable disruption events in your simulation as a scenario. If you would like to read a little bit about this particular work at a high level, it is, I believe, part of the chapter, but I put a link here in case you would be interested in the presentation. It takes you to a video as well as a short paper about, it's from 2020, but still, all the topics still relevant, how one can just start with a supply chain digital twin development. All right. So, This is what we had looked at. So for this project, for example, this is how we obtained this. We had a process twin. We were looking at the system. You see at the first row the type of sources our client used to get the data. We looked at hourly, daily, weekly data collected at these frequencies. We went through all the function details and learning details that we covered when we were discussing key functions. And you can see the advanced analytics and emerging R&D technologies that we have used. And in terms of use cases, we have done inventory optimization, production optimization, logistics, and resilience testing pieces. Again, there's a lot behind the scenes of this framework, but it is useful just to start the conversation and just to stop and just to see where we are. All right. Again, if you are interested, we also have some blogs about how we use different SaaS products in a way that we saw in that visualization of the supply chain. These might be also something that you might like to check out if you are new to the topic. But then you can, of course, replace them with your own tools. It might be just a good reading, and they are short, easy readings. Now, coming back here, let me just briefly talk about this particular piece. So this is in a factory, but this is for Georgia Pacific, actually. It's the paper production business where they use actually visual data mining and machine learning libraries. We have an event streaming processing and optimization to figure out their optimal operating settings for their machines. And it was done across large number of facilities, data coming from a lot of sensors and large data sets that were being used on a daily basis, and of course, a lot of models that had to be managed. So therefore, it's also important when you're working in these applications, you have a good model manager in place, because you might be developing a lot of models, assessing the health of your assets. At SAS, we use the model manager, but that is something that you just need to have a close look at. So through analytics and IoT, our client reported 10% improvement in equipment efficiency and 30% reduction in unplanned time. So I just noticed, as I was just getting ready, let me see. I just put this morning here. We had the conference at SAS Explore. If you just Google it, it takes you a limited on-demand experience. I just went to sign to watch. Then it goes to have the breakout sections, and there's a 30-minute presentation there. So if you would like to learn a little bit more detailed than what I mentioned here, how one can use machine learning and especially event stream processing tool to perform analytics on the edge for an asset twin, this might be a good reference that you might like to check out, especially if there are those of you who are interested in learning more about IoT applications. That would be a good reference, but it's for a limited time. So if you're interested, just have a look. And another use case that we often find ourselves working with is on aircraft maintenance. And actually, this is a Lockheed Martin use case that we also often talk about. It just starts with the historical fleet trends. Then you create perform prediction analytics to quantify the probability of failure. And it gives you an estimate about how long a part might just last. And then you can just move on to doing spare part analytics. You solve your stochastic optimization problem just to determine how many parts to have on your hand under the uncertainty of the length of the lifetimes of the products flying on these aircrafts. And the benefits that you see, as an example, one can achieve across the number of parts, aircrafts, and sensors as an example point. Of course, when you work with these data, just remember that you're actually working with censored data. So often, if you have a data set that represents the failures, some of them actually might be real failures and some of them might be no fault found. So often you are going to be working with right censored data. Make sure that the statistical models that you are using allow you to perform right censoring in the correct way. So a good place, of course, for me was the SAS's regression models, life regression, that allows you the censoring to handle. But there are also other tools where you can handle right censoring. So that is something to pay attention. Once you just jump over it, actually the rest of it you are going to be very familiar from the type of work we do at Informs. I would like to show one more use case in the last 5 minutes. So this is our actually an exploratory project that we had done at SAS. I like it a lot because this is where we just wanted to see if we can bring different technologies together. So there's a camera that is at the upper part of this area, and this is our actual cafeteria at the SAS headquarters in Cary, North Carolina. This is our salad bar, and our problem was just, can we create an AI that will in real time tell us how many cashiers we should have? You can have up to 4 cashiers, and again, the issue is not solving this problem. It's a very small toy problem. The objective was just to see, can we bring computer vision, event stream processing, simulation, optimization, reinforcement learning all together, and then can we create an AI that builds on this integration and in real time that can tell us how many cashiers we should have. So that was the purpose. And we did this, and actually we developed several patents out of this work, and it is now presented as maybe a way to perform in-store monitoring. So that was the purpose, not to solve the cashier problem, but really what type of applications businesses might be interested in that we built based on that integration. So computer vision AI, that is the camera looking down, and CV is basically creating data for us for queue length and entry and exit time. So it's a way to collect data. So this is why we had video as one of the sources of data. And this step was not as easy as we thought, actually. When we started to see, okay, what are the queue lengths? It was difficult for the computer vision to determine what a queue is. So it was sometimes going towards the salad bar, and the people who are taking their food, they were included in the queue. So our AI team had to come up with new methods of looking at this and really get us that queue lengths, entry and exit times. So, and one of our team members, just we were all working together, collaborating, and he said, okay, I just created the heat map of what is going on. And this is actually what our retail business loved, because you can look at the heat map of what is going on and you can just see where the shoppers are actually spending the time. So that was kind of a neat summary that was liked our business organization. Then we just took them. We created a discrete event simulation, a very simple simulation. But we were getting from computer vision queue lengths and entry and exit times. If I am developing a discrete event, very simple queuing simulation, I need to enter arrival times and I need to service times. So we had to take this data and transform it into that version from which we could develop a simulation. Often there might be a disconnect there, so that you just need to fill it in. Then we just use simulation to, let me see if I put it here. Yes, we use simulation as an environment to train the reinforcement learning agent. The queue length, cost of waiting, active resources. So this is the training module of an RL, reinforcement learning application. It's quite standard, actually. Once the training was completed with the simulation, we took simulation out of the picture and we simply relied on what the camera was showing us, which is referred to as the system. So as a result, what we had, this was the AI coming from the deployment part. At this moment, there is no simulation anymore. We are just getting the video from the camera. We are just tracking the last arrival count in the last 5 minutes. We are looking at the queue length, and actually once we jump into the yellow area, we are going to be told that we should open a new cashier. So this was the simple toy applications that we were actually very happy about, because we just brought all these different SaaS technologies together and we just created an AI that can make a real-time monitoring and resource control decision. I just put the next one here. I just thought you might like it. This is if we define average waiting time plus beta times cashiers as a performance metric. And this is where reinforcement learning results were for that particular metric. Random policy is up here, as you might imagine, because we are reacting in real time. If we had done simulation with fixed policies, this is where we were, and when we did the supervised learning, this is where we were. So that was a kind of nice quantification of the benefit of the AI that we just looked at. And this is the development framework, if we put everything into its place. Again, I would be happy to talk to you about more applications that you might be interested. I didn't put any finance, digital twin related examples here, but we definitely can discuss them as well. So to conclude, this is at a high level. I like this, considering our background. Assumptions, expert opinions, synthetic data just go in together with domain knowledge and historical input data. You optimize your system, then you put them into your simulation, you get your predictions, there might be alerts and reports. You do scenario analysis, and you can utilize risk management techniques and identify the corrective actions. But again, this should not be a one-off project. We are talking about digital twins, synchronization, and learning must be there. So these are the most important components that go in. And of course, filling the gaps for you to do that might just not be easy. There are a lot of interesting problems there. Synthetic data generation, zone of confidence, how do you perform fast sensitive analytics, and how to do fast effective simulation optimization are just some of the problems one might be interested. So there is definitely a lot of exciting, also theoretical work that requires consideration. So to conclude, digital twins, 4 required characteristics: a physical representation, a virtual characterization. Both must be synchronized, and there must be a closed feedback loop to enable learning and adaptation. Digital twin system help you get a holistic understanding of your system. It will take you towards optimal decision making. However, you always must start with a clear use case whose outcomes can be clearly stated and objectively quantified. This is the end of my presentation. I hope this was useful to clarify what a digital twin is. If you are starting on the topic, I hope it just gives you a good place to start. And I am happy to answer any questions you might have. Thank you.
Thank you, Bahar. That was very, very inspiring and very informative for me. So at this point, we have a couple of minutes for questions, and we welcome questions.
Hi, thank you for your presentation. It was very good. I was wondering, how do you handle the response time from this digital twin? Because I'm guessing when you do the synchronization, you need to run like the simulation to look ahead and then run some optimizers, a lot of things, right? But what about the real system is waiting for a response. So how do you manage that response time and to be sure that everything is going to come back on time so that the real time can take action on that?
So it really depends on where you are. If you are on the edge, then you are streaming data and you are working with the asset twins. So there, the response times is quite quick. But when we work with the process twins where the time is taking long, so we are not at the edge anymore. So we are often either on-premise or cloud or a combination of both, and it is something that takes time. It doesn't happen instantaneously. And if we are in the process-driven part, we also do not have to do synchronization on a continuous manner. We do it periodically as required by the frequency of our decisioning. So there's definitely a spectrum there, but it's also a challenge to run some of those simulations very fast. So we occasionally have cases where we have to wait.
Thank you for a very informative presentation. My question is similar to what the other person just said. When you actually have online synchronization, you have to make a decision whether this recalibration is needed or you are okay with it. Do you have any ways of determining, do you have any another digital twin of twin doing it?
I'm just answering the question building on my own experience at SAS. So we have tools that helps us to monitor the health of our digital models. So for example, we have a model manager that enables us to score these models. So that is also part of what we use in the chapter towards the end where we discuss implementation and challenges. I include a use case actually where the model manager comes into play. So it's a very good question, and then we just utilize our model manager to handle that issue. And underneath it all, there is a scoring algorithm that kind of determines when we should go ahead with the calibration or not.
Yeah, thank you for the presentation. Can you go to your slide 28? So my question is very similar to what is being asked already. Yeah, right there. So when you look at this, so after the synchronization and the online, so there is no feedback loop into the development phase again. So my question is, if there is an improvement to the physical system, so you have the digital system, so how do you now feed that back into that? Do you develop a new digital twin, or do you, how is that done? So that is one. Then you mentioned about monitoring the performance of the digital twin itself. Can you speak a little bit more about how that is done so that you can improve your trustworthiness in the digital twin itself?
Good point. So here I just moved ahead with the assumption that logic is already taken care of, but the logic of the flow might change over time. So then, yes, you have to go back to the initial phase of building your model, and maybe you're going to do some design changes. I just didn't account for that particular one. I just went ahead with the configuration is set, logic is set. Very good point. Thank you.
The health of the digital system itself to increase the trustworthiness.
Yeah, I think I would just think of it as part of the calibration process. So if you're not happy with the performance, like you would be quantifying the discrepancy between what the physical system is showing and what your digital twin is showing, your virtual model is showing. So when that happens, I think you can just think of the recalibration maybe in more general terms, even just incorporate logic changes into that aspect. So and then of course like a model manager would be also an important part of it. And when we work in these projects, there's always like the streaming data piece. So for example, a tool we use, event stream processing. So that's the data streaming in. I believe your question is a little bit related to the use of such a product.
So if I can put it a different way, so you have people using the digital twin, and they are going to be developing decisions based on the digital twin output. It's just like what we're having in AI. So they need to trust what is coming out of the digital twin to effect a change on the physical system. So how do you enhance that trust so that the human can actually implement it in the physical system?
I think I would, yeah.
Bahar, you might want to respond in a brief manner because we
Okay.
are out of time. And then I am sure you are going to entertain questions after
Okay,
the
of course.
tutorial.
I think I would just very briefly go back to the validation step. And there are some formal methods that you can just run the digital model with the real data, historical data, and then you have also historical records. Then you just quantify the discrepancy between them, and that might be a way of doing that. Thank you.